Hey everyone, can you hear me? Can you hear me well? You can post the message on the chat window if you can hear me. Hi, sir.
Hello, how are you?
I'm good. Nice talking to you again.
Yeah, absolutely. So I'll be your moderator again today. How have you been?
I think I've been good. It just feels like yesterday it was SDC. Time is flying by fast. It's already end of 2020.
Absolutely. Just rolling on by.
And I feel more confident in using Hopin now for the second time compared to my first time at the GC.
Yeah, it looked to me like all the session presenters were having a pretty smooth roll through there. So
All right, I'll start at 2:15. Isaac, it's 2:15. So do you have anything for us, or I can get started?
not at all. You're welcome to go, and I'm just gonna pull out of your way and let you do it. So
All right,
have a good one. Good luck.
thank you. Hey everyone, a very good afternoon. I welcome you all to this breakout session at Infotec conference. I hope you are having a great time so far. If you are watching this session on demand, I welcome you as well. I hope you and your family are staying safe and staying healthy. My name is Vaibhav Gujral, and in this breakout session, we will talk about Microsoft Azure Well-Architected Framework. The session is a very high-level discussion on what Microsoft Azure Well-Architected Framework is. It is not possible to cover everything within next 40-45 minutes, but I would like to assure you that by the time you will leave this session, you will have a fair understanding of what Microsoft Azure Well-Architected Framework is and how you should get started. And just a note, uh, if you have any questions or comments, feel free to post it on the chat window. I'll go back to them at the end of the presentation and try to answer as much as I can before our 45 minutes window end. Before we get started, a quick introduction. My name is Vaibhav Gujral. I'm based out of Omaha, Nebraska, currently working as a cloud architect at Kiewit. I am a Microsoft Azure MVP and a Microsoft certified trainer. I am a Microsoft certified solutions architect, and I hold numerous other certifications. I run Omaha Azure User Group, which is a community of around 900 people. I regularly speak at several user groups, events, and conferences like this one on Azure-related topics. I regularly blog on vaibhavgujral.com, and you can reach out to me on my Twitter handle, or you can also connect with me on LinkedIn. With that, let's get started. Before we talk about Microsoft Azure Well-Architected Framework, I want each one of you to answer this question. Is your cloud environment well-architected? Does your cloud environment has all the characteristics required to be qualified as a well-architected or a well-designed environment? Or let me take a step back and ask you, what is well-architected cloud environment? If you're not sure what well-architected means, I can solve that puzzle for you. A well-architected cloud environment has following characteristics. Number one, it should be very cost-effective and it should maximize your return on investment. It should be built and designed using modern DevOps practices. It should deliver high performance and it should use the right set of cloud resources in achieving that level of performance. It should be reliable and fault tolerant. In case of an outage or a disaster, it should fail over and ensure that your business continues without a major impact. Last but not the least, and the most important one, it should be secure. Now you have got an idea of what a well-architected cloud environment looks like. Now I want you to go back to my first question and think about it. I have asked, is your cloud environment well-architected? Does your cloud environment is cost-effective, reliable, and secure? Does it offers high performance and is it built and designed using modern DevOps practices? Don't worry if you can't answer that right now or if your answer is no, because that's true for most of the organizations. Likewise, if you have not moved to cloud yet and you are now planning to migrate to the cloud, then it becomes essential for you to architect and design your cloud environment the right way with the consideration for all the different characteristics that I have talked about in the last slide. If you will well architect your cloud environment, it will pay you off really, really well. Let's keep the ball rolling. In my presentations, I generally start with basics so that everyone is on same page and everyone in the audience can understand what I'm saying. This session is not different. When we speak of any public cloud, it is very essential to understand that cloud necessitates a shared responsibility model. If you think moving the workloads to the cloud will make the cloud provider responsible for everything, you are mistaken. It's a shared responsibility between you as a customer and the cloud provider. Unlike a traditional on-premises environment where you are solely responsible for everything, based on the cloud service model that you opt for, the cloud provider manages certain aspects of your workloads in a public cloud. If you are running your services in infrastructure as a service or IaaS in short, then the vendor is responsible for the physical infrastructure and virtualization layer. You as a consumer are responsible for patching your operating system, updating your middleware and runtimes. And last but not the least, you own your own application and data. If you move one step further and use platform as a service or PaaS in short, then you just own and manage your application and data. Cloud vendor manages the physical infrastructure, the physical layer, and the operating system and the necessary runtimes. Then under the last service model known as software as a service, cloud vendor manages everything from the physical infrastructure to the application, and you just consume the application and data. As you can see with each service model, the responsibilities are shared between the consumer and the cloud provider. This shared responsibility will play a key role in your architectural decisions because these decisions can have implications on your cost, security, and the technical and operational capabilities of your application. By shifting these responsibilities to the cloud provider, you can focus on bringing value to your business and move away from activities that aren't a core business function. Let's talk about Microsoft Azure Well-Architected Framework. The Microsoft Azure Well-Architected Framework is a set of 5 core principles or 5 core pillars to help enterprises build high-quality solutions on Azure. Microsoft has not invented any of those. Instead, all these are built on industry standards and recommendations. In fact, Amazon and Google also offer similar frameworks to help you design your cloud environments the right way. Now, there is no one-size-fits-all approach to design and architecture, but there are some universal principles that will apply regardless of the architecture, technology, or the cloud provider. These concepts are not all inclusive in themselves as well, but if you will base your cloud architecture on these principles, it will help you build a reliable, secure, and flexible environment. The Azure Well-Architected Framework consists of the 5 pillars that are listed there. First one is cost optimization, operational excellence, performance efficiency, reliability, and security. Under cost optimization, the recommendation is to design your cloud environment so that it is most cost effective for operations as well as development teams. Basically, you ensure that you are spending your money where you get the maximum return on your investment. In the process, you bring in efficiencies in your cloud spend and you avoid any wastage of your money. Under operational excellence, the recommendation is to take advantage of modern development practices such as DevOps, which results in faster development and deployment cycles. Then you also need the right monitoring strategy in place so that you can detect failures and problems before they happen or before they are noticed by your customers. Under operational excellence pillar, automation is another key aspect. Under performance efficiency, the recommendation is to properly match resource capacity to demand so that your workloads can perform well and can scale as needed. Azure offers a feature known as auto scaling, which lets you scale resources up or down dynamically based on the activity in your applications. In a nutshell, under performance efficiency, the recommendation is to design your architecture with performance and scalability in mind. Next on list is reliability. As the name suggests, it recommends to design the system while anticipating failures at all levels. Tell me what is the greatest fear of IT teams? Well, it's the fear of the system going down with no way to recover it. In a nutshell, failures are inevitable. You cannot ignore them. You cannot stop them from happening. They are bound to happen sometime, somewhere. The reliability pillar under the well-architected framework recommends to design your environment in such a way that it doesn't fail at the first place, and if it fails, it recovers from the failure within the stipulated time. Last but not the least, security. I think it is not really difficult to understand why security matters. I was showing the shared responsibility model in the last slide. Based on what we as a consumer are responsible for, we need to architect our cloud environment with the right set of security mechanisms in place. The pillar focuses on securing different areas of your cloud environment, ranging from infrastructure and platform services to your application and data. It might mean encrypting your data at rest or transit, or protecting your application against distributed denial of service attacks. Identities also play a key role in this pillar. Now, Microsoft documentation on Azure well-architected framework defines all these 5 pillars in great depth. I would strongly encourage you to go and read after this presentation in Microsoft documentation. But in this particular session in 45 minutes, we will touch upon these pillars at a very high level. And I would recommend to go and check out the Microsoft documentation for more details. I would share some reference links as well at the end of the presentation, which you can take for your further reading. Along with these pillars, Microsoft also offers an assessment review, which you can conduct against your current environment and generate an overall score and see some actionable recommendations. Let's talk about the first pillar in more detail. Cost is always a fascinating factor, isn't it? Whatever decisions an organization takes, cost plays a key role. Same applies for cloud. Utilizing cloud computing for your business needs a shift in your mindset. Quite essentially, it requires you to shift from capital expenditure model to operating expenditure model. In traditional on-premises environments where you pay upfront costs for procuring physical hardware and other equipments, you can claim the cost as tax deductions by showing them as a capital expenditure or CapEx. Whereas when you move to cloud, it changes the dynamics. You don't pay anything upfront. Instead, you pay for what you use. The capital expenditure in that case is zero, and you get a regular operating expenditure, most likely on a monthly basis. And shifting from a CapEx to an OpEx model forces you to be cost efficient in your choices. You must consume cloud services in an optimized manner. I have heard from so many customers that they don't really plan for the costs well, and when the monthly invoices start coming in, they get a huge shock. That's one of the motivating reasons to consider our first principle under cost optimization pillar, which says plan and estimate your costs. So before you provision anything in Azure, it's highly important that you plan and estimate your costs upfront. You can use any cost estimation tool of your choice, which gives you an holistic estimate of your total cost to move to cloud. You can also use the pricing calculator or the total cost of ownership calculator that is offered by Microsoft on Azure's website, which you can certainly utilize to get an initial estimate of your monthly outgo for your architecture. This ensures that you don't get shocking monthly bills towards the end of the billing cycle. It is very essential to estimate your costs upfront and inform your business about the estimated costs for running your workloads in Azure. The next pillar in cost optimization, next principle in cost optimization pillar is around cost optimization. It's just not enough to estimate the cost upfront and deploy your resources. You shall also keep looking for ways to optimize your costs. By optimizing your cloud spend, you can maximize your return on investment. There are many considerations to optimize your costs. For example, you should answer some of the questions like, Should we run SQL Server on an infrastructure as a service virtual machine? Or should we use Azure SQL database, which is a platform as a service? Should we utilize reservations or hybrid benefits to bring down our costs? The third principle around monitoring and analytics feeds directly into the second one. You must leverage monitoring and analytics tool available at your disposal to monitor your cloud spend and generate insights out of it. By looking at the historical cost information, you can easily identify the areas where you can reduce cost and eliminate wastages. Azure offers a full-fledged cost management solution which makes all the cost information available to you in a rich interface. It lets you not only see historical costs, but also forecast your future costs based on your historical usage. It also lets you filter your costs based on your subscription or resource group, or even at a resource level. In a nutshell, you must have enough visibility into your cloud spend, and you must understand how you are being billed for consuming those cloud services. Lastly, what hurts the most is those unnecessary expenses within your environment that could have been easily avoided. The last pillar addresses that concern. You must put in time in identifying these leakages. The sooner you do that, the better it is. In most of the cases, the reason for wastage is wrong sizing of the resources, where resources are provisioned with way more capacity than what they really need. For example, you might have virtual machines which could be underutilized, meaning the average CPU consumption might be just under 20%, or the memory utilization might be under 20%. It might be an ideal candidate to be downsized. It's not only the infrastructure cost that you can optimize or remove. It also includes operational costs. You can bring down your operational cost by automating your deployment process. In conclusion, in my opinion, cost plays the most important role in your architecture. While designing your cloud environment, always be aware of the costs. Here are some other ways you can optimize your Azure costs. Most of them are self-explanatory, like shut down the resources which are unused. Always remember you are billed for what you provision, regardless of the usage. So always be aware of usage and shut down the resources which are unused. Right sizing the underused resources is a no-brainer. Don't allocate capacity more than what is needed. As a thumb rule, I always start with the smallest size that I think is right for my workload, and then I monitor my workload, and as and when I get enough data to justify scaling up the resource to the next size, I do that. You can also leverage reservations and Azure hybrid benefits to bring down your cost substantially. Reservations lets you book capacity upfront at a heavy discount, whereas hybrid benefits lets you bring in existing licenses that you might have in on-premises. To handle variable and fluctuating workloads, you can utilize a feature known as auto-scaling, which scales your resources up or down based on the activity. Next on the list is budgets and cost allocations, which helps you make costs visible and make people accountable for their Azure costs. Last but not the least, always choose the right compute service. You might be better off using a platform as a service database, the Azure SQL database, at $10 a month than running a full-blown SQL Server virtual machine, which might cost hundreds of dollars. Let's talk about the next pillar, operational excellence. Operational excellence is all about ensuring that you have full visibility into how your application is running in production and ensuring the best experience for your users. Operational excellence includes making your development and release practices more agile, which allows your business to quickly adjust to changes. There are several principles under this pillar that you can utilize. The first one emphasizes on designing, building, and orchestrating with modern practices, aka DevOps. You must leverage processes like infrastructure as code, automation testing, automated deployments wherever possible. Always remember that DevOps is more about culture than technical. You need to drive the cultural change in your organization so that DevOps is embraced. Regardless of the size of your organization or the development practices that are followed in your organization, DevOps can be embraced and built into your system. The next principle is around monitoring and analytics to gain operational insights. Like the cost optimization pillar, monitoring and analytics play a key role in this pillar as well. You must have a monitoring, logging, and instrumentation strategy included in your overall architecture so that you can gain visibility into what is going on in your environment. You can use cloud native tooling like Azure Monitor, which includes log analytics and application insights, or you can also leverage any third party monitoring solution. Having a stable monitoring solution established in your architecture can help you multifold. It can help you troubleshoot and resolve performance issues. It can help you generate usage insights, and so on. Next on the list is automation. I can keep on talking about automation for the rest of the 45 minutes because automation is a no-brainer and it has so many benefits. For sure, it helps bringing operational costs down, but it also reduces errors in your process as the amount of human intervention is reduced. Also, automation can help you ensure that your activities are always performed the same way. For example, application deployments or resource provisioning. Last but not the least, the most underrated aspect of operational excellence is testing. I would be surprised if anyone who is attending this session comes to me and says they have not seen an angry customer finding bugs in the production system. 99% of these situations can be avoided if testing is included in our process to catch mistakes before they can impact the real users. Having a reduced number of reported issues by customers certainly improves our overall user experience. I'm sure everyone here would have seen a message like this when your application goes down. For example, I'm sure you would have faced this issue during one of those fancy online shopping days when the average volume of users for those e-commerce websites go 100 or 1000 fold. It has nothing to do with their application code as such. It has to do with the underlying resource capacity and scalability of the environment. Due to the increased volumes, it really stresses the underlying resources, and as a result, the site either becomes slow or becomes unresponsive because that kind of load was not planned for. And to address this concern, I want to talk about our next pillar, performance efficiency. In a nutshell, performance efficiency refers to matching the resource capacity with the demand. Performance efficiency includes scaling resources, identifying and optimizing potential bottlenecks, and optimizing your application code for peak performance. Like the earlier pillars, there are some core principles that you can leverage under this pillar. The first one is around scalability. It speaks about scaling out and scaling up. It is important to understand the difference between the two. Compute resources can be scaled in two directions. Scaling up refers to adding more resources to a single instance. For example, adding more CPU power or more memory to an existing virtual machine. Whereas scaling out is adding more instances. Instead of making a single instance more powerful, you create replicas of your instance and load balance the incoming requests. Do note that scaling up comes with certain limits. Obviously, you cannot scale up your instances to the capacity more than what is available in your physical host. That's where scaling out scores big time because theoretically, you can add as many instances as you would need. Be aware that costs play a key role in your decision making here. Every time you scale up or scale out, you are increasing your costs. You can leverage a feature known as auto scaling for the supported resource type in Azure. As I mentioned in one of the earlier slides, auto scaling feature scales up or down your resources dynamically based on the activity in your application. You can optimize your costs by utilizing auto scaling because you only provision resources as and when they are needed. Next in the list is your network performance. I think it's self-explanatory as well. When you're working on achieving an optimal performance out of your total environment, networking resources play a key role. You have to plan and design with the right set of networking resources to ensure that there are no network latencies or any other kind of performance issues related to networking. You might also leverage messaging patterns to make your subsystems loosely coupled. The benefit you get out of having a messaging layer in between your subsystems is that if your receiver subsystem takes more time to process each request than the rate at which the sender subsystem is sending, your system doesn't fail. Your sender keeps writing messages in a queue or any other messaging service, and the receiver keeps picking up the message from the queue. Similar to networking, storage performance also plays a key role in your overall performance. Speaking of storage, you must choose your partitioning strategy wisely so that you can maximize the benefits. If your partitions are not balanced, it might hit the performance of your systems really hard. Having right partitioning strategy also makes it easier to scale your system and improve overall performance. You must also consider caching to improve your application performance. Last but not the least, it's important to identify the performance bottlenecks in your system. These days, systems are complex and can have many subsystems. Performance of each of those subsystems contribute to the overall performance of your system. It is important to have right set of performance monitoring in place so that you can measure performance of different parts of your system, be it storage or compute or networking. Not only at the infrastructure side of things, our application themselves might be the cause for a low performance. Hence, it is critical to have the right set of monitoring built into our environment so that we can pinpoint the bottlenecks and fix them. In my opinion, it's a no-brainer that our cloud applications must deliver high performance, and we must utilize the right set of principles and design patterns in our architecture to ensure we receive the optimal performance. The next pillar on the list is reliability. In one of my starting slides, I did asked about the greatest fear IT teams have. It is the fear of the system going completely down without being recoverable. Most of these businesses are going digital and global now. Any of these businesses cannot afford systems going down whenever there is a failure or an outage. The reliability pillar addresses that concern. It provides guidance on how you can make your environments fault tolerant. It helps you make your applications resilient and highly available so that they can handle both localized and broad impacted incidents. If you will think about it, it is actually a very critical aspect. Our downtime directly hurts revenue. Imagine an e-commerce website. If it is down for half a day, how much revenue it might lose. The reliability pillar does not say that you should not expect failures. Instead, it says otherwise. It says that failures are inevitable. No matter how much prepared you are, failures are bound to happen. No cloud provider offers 100% SLA. The maximum that you get is 5 nines. So what really matters is how prepared you are in case something fails. Now, it could be any component of your architecture that might fail. It could be your application code or the data. It could be a networking misconfiguration, which might result in your application becoming unreachable. It might also be the physical infrastructure, like the physical hard drives might fail. There are a couple of principles that you must consider while thinking about reliability of your environments. The first one says that you must build a highly available architecture. When you are designing your environments, always consider the SLA offered by Microsoft for the specific services. If it doesn't meet your business continuity requirements, you must plan for high availability by adding appropriate redundancy in your environment. The other principle speaks about recovering from a failure. As I said earlier, failures are inevitable, so you must design your environment so that it can recover gracefully whenever a failure occurs. As a best practice, you must always have recovery point objective or RPO and recovery time objective RTO defined for your workloads. Recovery point objective refers to the maximum duration of acceptable data loss. It is measured in units of time and not volumes, meaning you will measure it like 60 minutes of data or 4 hours of data. In those 60 minutes or 4 hours, the volume of data might vary. Likewise, recovery time objective or RTO refers to the maximum duration of acceptable downtime. For example, if the acceptable downtime duration is 4 hours in the event of a disaster, then your RTO is 4 hours. Defining RPO and RTO can help you in designing the right capabilities in your architecture to meet reliability objectives. Now, this one is a no-brainer. Security is all about protecting your data that your organization uses, stores, and transmits. The data that your organization stores or handles is at the heart of your securable assets. Now, the data exists on some kind of infrastructure, which also needs to be secured along with the identities that are used to access it. It is highly important to have your complete security posture tight so that your data is safe and secure. There are few key principles that you might utilize. To start with, you must develop a defense in depth approach to securing your architecture. We'll talk about defense in depth in next slide about what it is all about. But in a nutshell, it requires you to make all the layers of your architecture secure. The other two are straightforward. You must choose the right set of technologies to secure your Azure infrastructure. It could be as simple as using network security groups or using an Azure firewall. Also, as I said earlier, it's important to secure the identities that can access your data. You must leverage industry best practices for managing your identities. You must also utilize features like Azure Role-Based Access Control and Azure Privileged Identity Management to manage control and access to important resources in your environment. Let's talk about defense in depth. It is a security risk management approach that defines multiple layers of security controls in an IT environment so that if a security attack is not caught by one layer, it will probably be caught by the next. The multiple layers increase the overall security score of the environment and reduces the probability of a security breach by a huge margin. Sometimes defense in depth is also referred to as castle defense because it resembles the security defense technique employed in castles. Historically, whenever in a castle an enemy used to attack, they used to first cross multiple barriers at the castle's periphery before actually attacking the castle. With the rapid expansion of cloud computing, the need for defense in depth strategy has increased manifold. What you see on the left is a snapshot of different security layers in a cloud environment. At the core is the data, which must be encrypted both at rest as well as at transit. The next is the application, where you must secure your application access by using services like Azure Application Gateways or web application firewalls. The next layer is your compute layer, which must be protected against potential threats like RDB brute force attacks or SQL injections. You can utilize Azure Security Center to generate a secure score and get recommendations for improving your overall security posture. Then your network is another important component to be secured. It is a no-brainer that you must secure your networks, and for doing so, you can utilize services like network security groups. Then comes the perimeter, where the most common form of attack is distributed denial of service attacks. Azure comes with a basic tier of DDoS protection enabled by default, and you can also opt for a standard tier. Then is our identities. We did talk about this in the last slide as well, and why identities are important to be secured. And lastly, the access to the physical data center must also be authorized. In Azure's case, it is managed by Microsoft, and only authorized personnel have access to different areas of data centers. For more details on defense in depth security, you can check out my blog post, for which I have listed the link down below. Lastly, cloud security is a shared responsibility. Each of the security layers is the responsibility of either the cloud provider or the cloud consumer. Here's the model of the shared responsibility we have seen in the starting. We can reframe this in the context of security now. Depending on the type of the service you select, some of the security is already built it into the service by the cloud provider, whereas other remains the customer's responsibility. As you can see, it is absolutely essential to use the right set of services with the right security controls to ensure that your overall security posture in cloud is intact. We have talked about the five pillars of the well-architected framework. As I have said earlier, there is no one-size-fits-all approach when it comes to the cloud architecture. The five pillars we have talked about offers you the guiding principles that you must consider while designing your cloud environments. And as I've said earlier, cost plays a key role in that process. Regardless of whichever other pillar you focus on, it might be reliability, performance efficiency, security, or operational excellence. Any changes that you make in your architecture, it will impact your overall Azure costs. For an example, to make your systems more reliable, you must introduce redundancy. Redundancy means adding more resources in your architecture. And the more resources that you include, the higher the costs will be. So it is a kind of balancing act between the cost and the other pillars. You must always consider the trade-offs between costs and other pillars whenever you are architecting your cloud environment. Once you have identified the priorities and the trade-offs, always remember to optimize your costs. On top of the guiding principles, Microsoft also offers an assessment review which you can take yourself. It is essentially a set of questionnaires targeted for different pillars. Once you provide the required information, it generates a score of where you stand in each pillar, and it also shares a set of recommendations, which are visible here. Let's go ahead to my browser and see how it looks like. So I'm here into my browser where I have already opened the documentation for Microsoft WellArchitected Framework. As you can see, it details all the different aspects of the 5 pillars that we just spoke about. You can go ahead and expand any of the particular pillars, and you can see all the principles that we spoke about and all the recommendations that Microsoft make under each of those particular pillars and principles. Then here is the review where you can assess your own environment and come up with a review. As you can see here, you can opt for one or more pillars that you want to get assessed for. Let's start with cost optimization. I'll click on next. It will ask certain questions based on which it will create a score. Let me select few options here and see what it does. It will ask different kinds of questions around that pillar. Since I have chosen cost optimization, it's opting for questions which are related to cost optimization pillar. Let me do this fast. And once I'm done with this, as you can see, it generates overall results for me. It says I have some room of improvement in my current environment for cost. It's my overall posture for cost optimization is moderate. My overall score is 41 out of 100. These are the different categories that have influenced my results. Since I have only applied the assessment for my cost optimization pillar, it is the only pillar which has influenced my result. It gives me some next steps where I can go ahead and probably implement auto scaling in my environment, tag my resources to do a better cost tracking. And I can also go and review a learning path on Microsoft Learn to get more understanding of well-architected framework. Then I can also go under each of these pillars and see the different category of recommended actions that it offers. Likewise, if you'll go ahead and assess your cloud environment against each of these pillars, you can generate all these kind of scores and recommendations. Another thing that I want to show you here is a very good learning resource if you are looking to learn a well-architected framework. It's published on Microsoft Learn and it's completely free. It is divided into 6 modules. First one is an introductory module to the well-architected framework, and then they have 5 other modules dedicated, each one of them dedicated for one of the pillars. Another tool that you can leverage is Azure Advisor. It analyzes your resource configuration and usage telemetry and then recommends solutions that can help you improve across all the 5 pillars of well-architected framework. It gives you proactive, actionable, and personalized best practice recommendations. For example, as you can see, the section for cost, it shows 3 recommendations. One is of high impact and the other 2 are medium impact. By taking actions based on the recommendations, I can save over $7,000 per year. Likewise, it also shows 31 recommendations for security, out of which 20 are of high impact. I can improve my overall security posture by taking actions based on those recommendations. You can also drill down into each of these sections to go through these specific recommendations and see the details for each of those. Recently, Microsoft has published or announced a feature within Azure Advisor, which is called as Azure Advisor Score, that helps you improve the overall posture of your cloud environment. As you can see, it gives an overall score. In the example, it is 90%. Then it also shows a historical trend of your score, which might be very helpful in ensuring that you are on the right track. Lastly, you can also see the scores for each of the category as visible on the right side. Microsoft has also published a good chunk of design patterns, which can be very useful in designing your cloud environments in accordance with the well-architected framework. Each of these patterns describe the problem that the pattern is addressing, considerations for applying that pattern, and an example of how you can implement the pattern in Azure. Most of these patterns include code samples or snippets that you can use to actually implement the pattern in Azure. Do note that most of these patterns are applicable to any distributed system, whether hosted on Azure or AWS or any other cloud provider. I have listed a link there for the page where they have detailed all the different cloud patterns. In addition to the Azure Well-Architected Framework, you can also leverage the Cloud Adoption Framework to better align your business and technical strategies. It provides best practices, documentation, and tools that you and your teams can utilize to successfully achieve your short-term and long-term objectives. In addition to each of the pillars that we spoke about for well-architected framework, there are some consistent design principles that you should consider throughout your architecture. To start with, you should use evolutionary architecture. No architecture is static, and you should allow for evolution of your architecture by taking advantages of new technologies, new services, and new tools as and when they are available. You should make your decisions based on data. You should collect data, analyze it, and use it to make decisions surrounding your architecture. It could be cost data, performance-based decision, or it could be any kind of decision that you are making for your environment. Educate and enable. Cloud technology evolves quickly. Educate your development operations and other teams to help them make the right decisions and build solutions to solve business problems. Documentation is also critical within your organization. Lastly, automate. Automation of manual activities reduces operational costs, minimizes errors introduced by humans, and provides consistency between environments. All right, we have talked a lot in these last 35 minutes or so. I would like to conclude with an overall summary of what we have discussed so far. Architecture is for sure the foundation of your environment's design. Using the Azure Well-Architected Framework will give you the confidence that your app can sustainably meet the needs of your customer, both now and in the future. The architectural priorities and needs of every application are different, but the 5 pillars in the Azure Well-Architected Framework are an excellent guidepost that you can use to make sure that you have given enough attention to every aspect of your application. Just to summarize, the 5 pillars that we discussed include cost optimization, operational excellence, performance efficiency, reliability, and security. Focusing on these pillars when designing your architecture will ensure that you are laying a solid foundation for your applications in the cloud. With a solid foundation, you will be able to drive innovation through your environment, build solutions that your users will like, and foster the trust of your customers. Here are some of the resources that we have talked about earlier. I hope you will find this helpful as well for your further reading. With that, I conclude my presentation. I will respond to questions in the chat window if there are any. Thank you all once again for joining. Stay healthy and stay safe. Wear your mask and have a very good holiday season. Thank you.